Good bird, bad bird.
Maybe scoot over a little bit, because I'm going to be a detached head, or a detached voice.
Okay.
All right, yeah, I'll peek in once in a while. I'll just be half a Phil.
Hi.
Am I half Phil? Is it half Phil?
Feel light.
Or is it half full?
Okay, let's look at these robots.
Yeah, let's start with Robot Girl. Okay, Robot Girl, unmute your mic and
Show us your robots.
show us your robots.
Yes. Okay. So, yeah, it's working. Okay. So basically, I made something with Chris's XP network protocol. So I have 3 nodes on the mesh network right now. And the first node is this one where it's sort of like a sensory node. And right now it has a pulse sensor on it. And each time it detects a pulse, then it sends it to the network where both RoboBirds are listening to it. And then this RoboBird, since it uses the NFC hats functions, it can modify the actions when a pulse is received. So, for instance, this may or may not work, but
Live demos always work this way. Totally cool. Don't worry about it.
see, pulse sensors don't really work on robots.
Not yet. Not yet.
Alright, so right now you can tell it's sort of like this robot flaps its wings when it detects a pulse, or it shakes when it doesn't. But when I add on the robot badge hat, then it will do, it will open and close its beak, and this one is chirping. So it works with like all the different hats, just different actions and stuff. Let's see. Yeah, so that one is just that way.
Yeah. That's so cute.
Yeah, so it's just really simple but fun.
This is neat. So this project's been evolving for a while, and now you're using Chris Courtwright's RiderNet that was originally used for horses, and now it's crossing over the horse from horses to birds.
Horse-bird boundary.
Yeah.
I'm glad you don't work on like viruses or like biotech stuff, because I'm glad it's this robotic stuff. I think this is really good. Are you going to be posting any information about this down the road when you're finished with it?
It's
Maybe?
sort of working, but it's not good enough yet.
Okay. It'll take time.
Yeah.
Let us know when it's posted, and we'll do a little post about it. And also for everybody who's watching this, because you do an awesome Hangout, when could they join a robot Hangout if they wanted to do a robot Hangout?
So yeah, I do a robot party, and it's every Thursday at 8 p.m. ET.
Okay, Thursday at 8 p.m. Get your robots. You have a bunch of robots. You had a robot party.
Yeah.
You did a robot party video. You can maybe get your robots and join up.
Yeah. I don't have as many robots as I used to. I need to get on that.
You still have 1 or 2.
I do.
Okay.
Okay, Robot Girl, thank you so much.
Thank you, Robot Girl.
Yeah, no problem.
Fulfilling our robot needs.
Okay. All right. Next up, who came in was Zach. Zach, unmute your mic. And I see some technology here. Yeah.
Hello.
Hello. So I just wanted to show a little personal project I've been working on. I do a lot of professional projects, but this is a fun personal project. So I'm going to the Gathering for Gardener coming up in a little while, I guess a month or 2, and they have a gift exchange, and you bring 400 things, and you end up with 400 different things. It's a really neat way to sort of get introduced to a lot of people.
There's a lot of things.
It's a lot of things. So I had to come up with something that was very inexpensive and easy to put together. So, and it's a puzzle conference, and so I figured I'd make a puzzle. And so I made this. This is a prototype. I've got 400. Let's see if I can get it close, if it'll focus.
Looks like there's an LED and there's some buttons.
Yeah, so I'm calling it the minimal electronic puzzle. So it's basically just got a single LED on it. It's got a 2032 battery holder. It's got a little 12F 1822 pick.
Yeah.
And it would have nothing else except there's a MOSFET on it that so that if somebody flips the battery in backwards, it doesn't fry the pick. Couldn't figure out a simpler way of doing that, or a less component way to do the same thing. But so that's basically it. But it's through all kinds of puzzles that you can solve on it. So you can imagine. In fact, I can put the battery in.
And
So
the capacitive touch
you've got
pad.
capacitive touch pads, which give you they're both numbered and they have arrows on them. So you can imagine different puzzles that you could do with that. And then it also sort of takes advantage of a number of kind of less obvious ways of using the features of the chip to do interesting things. So in fact, it interacts with at least 3 different devices around your house through sort of non-standard means. You don't actually connect anything to it. You don't have to know anything about electronics. But through the course of solving the puzzles, you hear audio and music. You get data to and from a computer. There's a variety of things. Which, if I told you all, then somebody would find this and would solve all the puzzles without solving them.
Yeah, I like the LED, the little minimal LED projects that use the LED. They back bias it, so it can be an input.
Right.
As well as an output.
That could be one of the features on this as well.
Possibly.
Could be.
Stop it.
That's right. We don't want to.
That's not an unfair thing. I don't even see this thing.
Well, of course. So yes, you're well versed in probably all the unusual ways of using these few components. But you could imagine all the different ways you could do it. It's actually a lot of fun.
Did you check out the one component FM transmitter?
Maybe.
Okay, I'm getting pretty close here.
Yeah.
There's what you can do with only a trace.
Exactly.
You can do an AM radio, right? You can do an AM radio with a wire and a microcontroller.
You might be able to.
I love microcontrollers. I love microcontrollers. They're so great.
Absolutely.
Okay, I want one of these.
Well, I'm making 450 of them, so because it doesn't really cost much more, so we'll see.
If you send us one, we'll trade you something.
Our CTO loves puzzles.
Yeah.
And we will
Excellent.
trade you something really cool.
I'm sure you could. So yeah, I'll send you one.
Send it to us after he's done with the latest Git pull, so that we don't have him.
Yeah, we have some big updates this week.
And I hope he doesn't watch this, so he has the hint, because he doesn't know about these tricks.
No. We'll tell him the show and tell was canceled.
Okay.
Okay.
This sounds really cool. So this is a Gartner.
Gathering for Gartner.
A private thing.
I think it's by invitation, so I guess it's private.
Okay.
But
if there's websites and stuff, you can post a link just in case people want to check it out.
Absolutely.
I'm not a big puzzle person actually, but all of my friends at MIT did Puzzle Hunt, and it was I would not. Yeah, it was awful. Oh, it was memories of late night.
Yeah. Hey, just real quick, what scope do you have behind you there? Which
it's a Rigel.
Right.
Yeah, it's a 4-channel.
The 4-channel one. Yeah, I needed a 4-channel scope, and it actually works pretty well.
Yeah, I think one show and tell. I think we might do a show and tell where we ask everyone to show us their workbenches and show us their scopes. I think that'd be kind of fun.
Yeah.
Anyway.
Yeah, I big scope and microscope over.
Oh yeah, look at
there.
that.
Yeah.
Okay.
How are you going to make all these boards? Are you actually pick and placing them by hand and then reflowing them with a toaster, or what's the?
Probably. I can knock it out pretty quick.
I have a tutorial about it. You can check it out. I mean.
No, I do that all the time, so it's not a big deal. But I know I may have my assembly house do it that I normally send my stuff to,
totally
but
easy.
yeah, paying somebody to do it is actually much easier than doing it yourself.
I did 200 SOIC boards with a couple of passives in a few hours, but this looks like it's a little more complicated. It's double-sided. So.
Yeah, it's double-sided stuff to reflow.
Yeah, I mean that's the thing. I mean, you would reflow. I mean, on one side you've got the LED and the MOSFET, and on the other side you've got the SOIC. So, it's kind of a toss-up. I'll just knock it out real quick by hand. I mean, it's not that big a deal.
No big deal.
Okay, well, when you're all done, if there's anything you can, when this is all out and the puzzles are solved, feel free to send us information about it. We'll post it up on the blog.
Absolutely.
Okay, thanks so much, Zach.
I think I had some good guesses.
That was a good guess. Okay. All right, Ethan, unmute your mic and show us your project.
Okay, so I have a... Can you guys hear me?
Yep.
Yeah.
Loud and clear.
Okay. So I have a small quadcopter I've been working on with my dad. Really small.
Oh, that's so cute.
That's cool.
Yeah.
And what we decided to do was how to make it as cheap as possible, so hold on. Oops.
Let's see what's going on here.
He's just in like show image. Oh.
There we go.
Wow.
He's better at this than you.
Yeah. Yeah, how did you switch cameras?
There's a setting button at the top.
Oh, if I touch that because we're doing on air, it'll stop everything.
Okay, so that's cool. Did you guys design this board?
Yeah.
Cool.
So I designed. My dad's helping with the software. So we use the PIC32 in the middle.
Yeah.
And there's just some power circuitry, and there's a bunch of different ports. Like, let's see. This is where all the
Yeah, I see a little
servos.
boost or something, or buck converter there.
Yeah, there's a boost and a buck, and the boost one actually stopped working. But so all the little motor controllers plug in right here. And this is for air pressure breakout from SparkFun. And a bunch of other little things, and then on top is a MU6050 from InventSense breakout board.
Yeah.
With magnetometer, that's what we're using for sensing. And we haven't got much figured out yet for software, but it does spin the motors, which is pretty cool.
Yeah.
That's cool.
Have you been following some of the quadcopter stuff on our site? There's a guy, Charles, at MIT, and he has a little quadcopters. Have you seen what he's been up to?
Yes, T-copter.
I've been trying to catch up with all of it. There's so much of it.
The thing about the NPUs is that they don't give away the register file.
Oh, yeah.
So some people have been reverse engineering it, but it's really hard.
Yeah.
One of the problems with this NPU.
And how are you going to control? You're going to do a remote control at first, and then.
Oh, actually, that's another interesting thing. Is these little Bluetooth dongles, USB.
Oh, yeah.
The PIC can host USB, so we're either thinking about finding a way to talk to this and control it from like an iPhone.
Oh, yeah.
Or use one of the serial Bluetooth modules.
Yeah, and you can send keyboard commands over.
iPhone doesn't connect to normal Bluetooth devices for serial data, but an Android phone will. It's the one thing that, because I looked into this, it's the one thing that Apple killed from their iPhone, from the iPhone, is it can't connect to standard Bluetooth modules. It can only connect to keyboards.
Yeah.
So you have to do sneaky stuff, or you can just use an Android phone, and there's example code out there for that.
Yeah, or control it from my computer. We'll find out.
Or use your computer.
This is really neat. So we have been awarding badges to people who are doing interesting things, and we have a quadcopter badge. Can you send an email to support@adafruit.com? We're going to send you out a quadcopter badge.
Oh, that'd be nice.
Yeah.
Yeah, it's cool. It looks like a quadcopter.
Yeah.
It's like a friendly quadcopter.
Yeah, and just send a note to support@adafruit.com, and we'll send you out one, and I'll also send you a sticker. We get both.
Cool.
Awesome.
Okay. All right, Ethan. Thank you so much.
Thank you.
This is fantastic. All right, and Jerry out in Hawaii. Hello. Unmute your mic. Show us your project.
Aloha.
Aloha.
I was hoping to show you a whole lot more, but as I started setting things up, once again my power supplies crapped out on me. Fortunately, I have 2 of your 5-volt 10 amps on order. Hopefully, they get here this week, please.
Excellent.
Meanwhile, my LED project has morphed into a rather large beastie, adding more and more processors as I went, devices and things as I went along. There are 5 strands of LED which are on the wall behind me now, hanging up, but unfortunately I don't have the power to power them. The control shield. Currently, everything's wiring on to one of your screw shields, which is really helpful because I get to screw it together and test it to make sure it works, and then I solder it in, and it all screws up, so I have to go back and resolder. But it's gotten more and more complex as things have gone on. There are now, let's see, 4, 6, 7, there are 8 different connectors coming off of it. For a couple of infrared detectors, a weather station, 2 buttons, and a serial I/O that goes off to the other Arduinos that run the LEDs. There's also where to go? Here it goes. a while back, I don't know if you remember the Verbalizer was around in July. They sent me one, and it's been sitting in the box going, what do you want to do with me? What do you want to do with me? I don't like Google Voice, so I wasn't going to use Google Voice with it. But I figured, okay, it's got a microphone. Cool. I can hook it up and do an audio input to the thing, so I can make an audio spectrum analyzer on it. I got some of the code working for that, and at least I thought I did, and I went to try it again this morning, and it didn't want to work. So I may be using an old version of code, and I have to figure out which one I was using. Having multiple projects going on or multiple control programs, you really have to manage your software better than I have been. But it's got the audio, and the fun thing is later on it's got a Bluetooth module in it too, so I could have a Bluetooth control for it. But that feeds to the main module, which has all the other things. And then because really what I was trying to do before was build a weather station, I added back in the barometric pressure and the temperature humidity sensors just for fun. But when I did that, I realized I'd run out of I/O devices, and I couldn't put my display board on there. So I have one of your little TFT displays, and I threw a Teensy on it, and had to change all the pins from all the documentation, of course, because the Teensy's different. But it works, and it will be my display to tell people what mode we're in and what temperature and humidity and so forth we're in.
I think you need some more features. Could you add, could it be on wheels? And, maybe it could be a line-following weather station.
I haven't decided to let it be mobile yet, but it all has to go into a waterproof enclosure and go out to the Source Maui, which is our local Burning Man event type thing out in KNI, where if it rains this week like it usually does, it will pour. So everything has to be kind of waterproofed. Makes for an interesting thing. The tutorials on the tape doesn't talk about how to reseal up the tape. And also, I found some oddities when I was cutting the tape that were different than the way your tutorial says to cut the tape.
Well,
but
if
it
you
all
have
worked.
For outside volcano, Hawaii, pouring rain stuff, let us know. We will add it.
I will, and there'll be a nice big post about this thing once it all gets running to document. I'll find a good place. Where do you guys suggest putting code for something? Is GitHub the better thing for an open source type projects, or?
We like GitHub, but that's...
Use whatever you feel most comfortable with. There's a lot of options.
We like GitHub. It's free hosting for open source projects. So, and if you ever want people to contribute, it's really easy for them to fork and do stuff. We use it for our stuff. So that's we're not connected to them at all, but we find it very helpful for us.
Appreciate that. I've noticed most of your stuff is there on GitHub, and a lot of the stuff I've been pulling in from people it's great. Yeah. So I'll probably throw everything up there and build a project page and so forth. Okay, anyways,
when you get your thing working with a barcode scanner, let us know too. I think that's the last thing that's missing out of this.
Well, the RFID also needs to go in there too.
There you go. You
got plenty to chew on.
You got plenty of projects to work on. Okay.
Yeah, I got all the I/O devices laying around. I got to use them for something.
Yeah.
Exactly. All right, everybody.
All right.
Thank you so much. We're gonna sit down, and then we're going to do Ask an Engineer.
Okay.
Thank you,
Bye, everybody.
Robot Girl. Thank you, Ethan. Thank you, Jerry. Thank you, Zach.
Thank you.
All right.
Hi, Aaron.
And